Welcome to Introduction to Computer Science, Computer Software. This is Lecture B. The component, Introduction to Computer Science, provides a basic overview of computer architecture, data organization, representation, and structure, structure of programming languages, and networking and data communication. It also includes some basic terminology from the world of computing. The learning objectives for this unit, Computer Software, are to define computer software and major software types, describe application software classification and provide examples, including those focused on healthcare. Define what an operating system is. Explain the features and functions of operating systems. Classify operating systems. Describe commonly used operating systems. Describe types and major attributes of files. Explain the purpose of file systems. Provide file management tips. And identify different implementations of file systems. This lecture defines what an operating system, or OS, is, and explains the features and functions of various operating systems. System software consists of programs that control and maintain the operations of a computer. There are two types of system software: operating systems and utility programs. Often the distinction between these two types is not clear, because utility programs may be considered to be part of the operating system. The operating system of a computer is the set of programs that coordinate all the activities of the computer, including all the hardware, commonly referred to as resources. Think of an OS as the layer between the computer hardware and the application software. OSs are unique to each individual hardware system. A version of Microsoft Windows running on a desktop will not run on a smartphone. A different version of the Windows operating system would be required. Here is an example of how an OS works and what it does. Suppose you want to print a document from a word processor. First, you start a word processing program by, say, clicking on the desktop icon for that program. The OS registers the mouse click and knows that you want to open the word processor. It finds where that program is stored on the hard drive, loads it into memory, and starts the program. After the program has started, you find and open the file you want to print. The word processor requests the file from the OS. The OS finds the file on the hard drive, loads it into memory, and sends the information back to the word processor. The word processor then displays the document. When you select the menu option to print, the word processor sends a request for a print job to the OS. The OS sends the document to the printer, and the printer prints it. Without the OS, the application software would have no way to talk to the system. In this example, without the OS, the word processor would not be able to find the file on the disk, load the file into memory, view it, or print it. The OS does a lot of things. It interfaces with the user, giving the user a way to tell the OS what he or she wants to do, boots the computer when it is powered on or restarted, configures any devices connected to the computer, manages processes. When a program is running, it is called a process. Hardware resources, memory, and files. And finally, the OS provides computer security. Operating systems interface with users in several different ways. One way is through the command line. In this paradigm, the user types commands to interact with the OS. So instead of starting a program by clicking on an icon, the user would type the full path to and name of the program to get it to run. Some operating systems that use command lines are DOS, Unix, and Linux. To see a DOS command line in Microsoft Windows, click on the Start menu, type Run, press the Enter key, type CMD, and press the Enter key again. The OS will bring up a command line window. To view all the files in the current folder, type the command dir, which will list all the files in the folder. Today, most operating systems provide graphical user interfaces, or GUIs, to interact with users. Users can see visual representations of files and use the mouse to click what they want to open, run, print, copy, or move. Some examples are the GUIs in operating systems, such as Microsoft Windows, Mac OS, Mac OS X, and the GUI windowing systems available for Linux. Linux does not include a GUI windowing environment by default. Instead, there are several to choose from that will work with Linux. We will discuss some of the various operating systems in the next lecture. Booting is the first task that happens when the computer is turned on. For an explanation of why this process is called booting, see the references slides at the end of this presentation. Booting starts the basic input-output system, or BIOS. The BIOS represents the set of instructions stored in the read-only memory, or ROM, that execute when the computer is started. ROM is non-volatile, meaning it persists after the computer is turned off. ROM is mounted on the motherboard. The BIOS, in turn, starts the OS. The kernel starts and continues to run as long as the computer is on. The kernel refers to the necessary core parts of the OS that need to run all the time. Next, other parts of the OS, such as utility programs, are started as needed. The OS then checks to see what devices are connected to the computer and whether they are configured properly. If something is not configured properly, the OS will try to reinstall the driver if it can. If it is unsuccessful, it generates error messages or pop-up windows, prompting the user to locate and install the device driver. Other applications are then launched according to startup scripts defined by the user. Note that the BIOS itself has a user interface. It can be accessed by pressing a particular key when the computer is booting. It provides a menu for configuring the system. Be aware that changing anything in the BIOS can render your computer inoperable. Devices are hardware components that are connected to the computer, for example, a printer or a scanner. The OS needs a program to communicate and control each device. That program is called a device driver. Each driver is unique to the OS and the hardware device. After a device driver is successfully installed, the OS can control the device. If the device driver becomes corrupted or overwritten, a new one must be installed. Also, when there are any changes in the system, another version of the driver must be installed. When you get a new PC, you have to get drivers for all attached devices. New devices require new drivers. Upgrading the OS may require new device drivers, which are usually available online at the device manufacturer's website. If there are no new drivers available for old devices, these devices become obsolete. When a software program is running, it is considered to be a process. Most PCs today have only one person using them at a time, but one person can have multiple programs or processes running simultaneously. Originally, operating systems were single-user, single-tasking, which means you could run only one program at a time. Larger servers allow multi-user multitasking. In a single-user setting, the OS responds to the user's mouse movements and clicks to determine which window and process are active. In multi-user systems, the OS has to make sure that the user's processes share the system resources appropriately. If the program or process is not in memory when the user wants to use it, the OS has to load it. Recall that memory is limited in size, and it is possible that not all processes can be contained in memory at once. When this happens, the OS can load only some of the processes at one time and has to switch to other processes when needed. Only a limited number of processes can be active simultaneously. However, even in a single-user setting, it is possible to have multiple processes active at once. For example, a user may be downloading an MP3 file while printing a document and writing an email. The OS has to manage which process is running at a given time, or multiple processes if there are multiple processors, and how these processes share the computer's resources. Computer resources to be managed include the Central Processing Unit, or CPU, and there may be more than one, the Random Access Memory, or RAM, devices, secondary storage or disk storage, such as the hard drive, and a network interface. The operating system controls processes that in turn control resources. The OS implements a scheduler for sharing the CPU's time so that each process gets a fair share of time. It gives the illusion that multiple programs are running at the same time, even if there are more processes than CPUs. Each process gets a small chunk of time per turn, and the processes are switched so quickly as to be barely noticeable. Also, the OS controls how devices are shared among processes, for example, maintaining a print queue. Finally, the OS provides access to memory, secondary storage, and the network. Every OS has a way to view processes that are running. In Microsoft Windows, it is the Task Manager. The Mac OS has the Activity Monitor or Process Viewer. In Unix and Linux, the top command provides a list of processes. This view shows information such as the names of all the processes, who started the process, and how much CPU time and memory are being used by each process. This screenshot shows the process viewer in the Linux OS that runs K-Desktop Environment, or KDE. The process viewer is started by typing the top command at the prompt. The OS manages accessing memory through memory addresses and retrieving or storing data to or from memory. Even though the amount of RAM on most modern computers is rather large, it is still limited. To give the illusion of unlimited memory, modern operating systems use virtual memory. Virtual memory is much larger than physical memory. The OS manages mapping the virtual memory to physical memory. The OS uses hard disk space called swap space for that part of memory not currently loaded into physical memory, or RAM. Ideally, the processes in swap space are inactive processes. Swapping occurs when a process's instructions and/or data are loaded from swap space into RAM, and some other instructions or data previously stored in memory are then saved to the swap space. This swapping is very time-consuming. A computer that is running many programs and has too little memory will demonstrate significant slowdown as the user tries to do things within a program or to switch programs. The entire system seems bogged down. Adding more RAM to the computer can help speed things up. A file is a set of computer instructions or data treated by a computer as a single unit. Files are organized into folders or directories. The OS uses a file system to control how these files are stored on disk in secondary storage. The file system provides the user with an interface for viewing and manipulating files. Some of the operations facilitated by the file system are listing, viewing, copying, renaming, moving, and deleting files and directories. These functions can be accessed from a GUI or command line interface within an OS. Also, the file system allows application software to access files and folders. We will return to the file system and file management in the next lecture. Finally, the OS provides low-level security. It runs all processes related to the OS in system mode, meaning users cannot access the processes. It can provide user accounts and access rights to protect access to the computer and the file system. Also, current operating systems can be configured to update automatically, which means that any security holes can be patched quickly. In addition, current operating systems can include integrated firewalls, which can protect the computer from unwanted network access. Regardless of the security features of modern operating systems, users still need to install security applications. These applications provide the most thorough and up-to-date protections against malware, including viruses and spyware. So far, we've been talking about only one kind of system software: operating system software. If you remember from earlier in the lecture, there is a second kind of system software called utility programs. These programs perform system tasks like backing up files, diagnosing system problems, searching for a file, and compressing files. Also, these utilities can enable the use of computers by those having a disability or impairment, for example, increasing all font sizes for easier reading. These utility programs may come with the installation of the OS, or may need to be installed later. Also, some experts consider utility programs to be part of the OS, while others do not. In any case, the OS and the utility programs work together to make computers usable. This concludes Lecture B of the Unit on Computer Software. In summary, this lecture defined what an operating system is and delved into what operating systems do. Operating systems control all the functions of the computer and act as an intermediary between the hardware and the software. They also provide a way for the user to interact with the computer. There are many different versions and brands of operating systems. Each OS is unique to a particular computer hardware system.